Good morning, my dear students. This session, we will go for one more example on parabolic geometry of three hinged arches. Let us see the question first. Show that the parabolic shape is a funicular shape for a three hinged arch subjected to a UDL over its entire span. Right. The question, if you can read it carefully, that the parabolic shape is a funicular shape for a three-hinged arch subjected to UDL over its entire span. So what does this mean, funicular shape? So if you take an arch, if you load that arch, the arch, anywhere you pick a point on the arch, you calculate bending moment. The bending moment value should be 0. That in the other way, what does this funicular shape means? What does it mean? Okay, so you take any point on this arch A, B, C, then calculate bending moment. The bending moment value should be 0. Means what? The arch should have only compression in the arch. Okay, so there won't be any bending moment in the arch. That is the theory behind this funicular shape. So that is what we call theoretical shape. Okay, theoretical arch. So now in this case, where if you have UDL over the parabolic arch, both theoretical and actual arch coincide. This is the other way of telling like what is funicular shape. Okay, so in short, mathematically, if you want to say, you calculate bending moment anywhere in the arch, the value should be 0. That you have to prove it now, because it says show that the parabolic shape for the three hinged arch given. There is one more hinge that you find at C. So that you have to prove it. So what do you do now? You take a section anywhere in the arch, write mx equation. So if you can prove that mx is 0, means for any value of x, bending moment is 0, then the statement is proved. Okay, this is what we need to do. So anyhow, to do that, prior to writing mx equation, what exactly you need? So before you write bending moment value anywhere in the arch, to write bending moment, you must solve for support reactions. Then only we will be able to write bending moment value. So for example, if you take a section here, if you want to write bending moment value, sum of all moments to the left or to the right. So what you need is these reactions. Okay, so then only it is possible to write bending moment value. Right. So the solving for support reactions is very similar to the other examples that we have discussed earlier. So let us find the full free body diagram of the arch to start with. Then apply three equilibrium equations. This is all similar to the earlier cases that you have solved. So first take free body diagram of full arch, then apply equilibrium equations, then find VA value, VB value, and H value. So why I am calling this as H? Because when you apply sigma fx0, HA is equal to HB is equal to H. This is already known to you, right? So from symmetry, if you see that this uh, midpoint of the arch where C at location C, to the left of C and to the right of C, all the conditions are same, so I call this as symmetry. So because of symmetry, total load acting on the arch will be shared equally by support A and support B, which means VA is equal to VB because of symmetry. So otherwise, there is a very regular procedure that you have. You apply equilibrium equations. Don't worry about all the symmetry and all. So that is already there. Okay. So you are always permitted to calculate by using equilibrium equations. When you want to use some short way of doing, you can use such symmetry and all. So total load is W into L. So half of that is W L by 2 is one of the reactions, and the same here, W L by 2. So that is what is written here. So VA is equal to VB. Reason? Because of symmetry. So VA is equal to VB. Then how you get H value? Horizontal reaction is again by the same procedure. Pick half of the arch, either to the left of C or to the right of C. So taking left of C, what we do? We apply sigma MC0. I'm again repeating the procedure, whatever we have done for earlier problems. So for portion AC, you are applying sum of all moments at C is equal to 0 to the left of C, taking the notations as beam notations for moments uh, uh, to identify whether it is sagging or hogging. Okay. Right, to the left of C, you have three loads. One is VA, another one is H, another one is UDL. So writing the moments VA into the distance L by 2. From C, VA is at a distance of L by 2. So you know VA value, WL by 2. Right, what is the direction? Clockwise. So VA is going to cause clockwise moment at C. So direction is clockwise, left clockwise positive. Right. Then what about UDL? So UDL value is W into what is the span to the left of C is only L by 2. The total load acting to the left of C. So, right. So that is total load. What is the distance? Half of L by 2. So L by 2 divided by 2. So what that it become? L by 4. And what is the direction? Anti-clockwise. Means what? Hugging minus. Then what is the other force remaining? H. So H into, right. What is the distance? Rise value. Small h. Okay. What is the direction? Anti-clockwise. So what you write? Hogging minus is equal to 0. So substitute for VA. So only unknown here is H, because L and H, W, all other are given values. So you are going to get WL square by 8H, 8 into small h is the horizontal reaction value. Right. So now you are ready with the support reactions. WL square by 8H. So now you are ready with the support reactions that are required for writing mx value. So pick a point on the arch at a distance of x and write mx equation. So how do you write mx equation? So let us see that. So VA into distance is x. That is the first term. Let us see here. WL by 2 is the reaction VA into what is the distance? This is x for this location. Right. What else you have? Horizontal reaction into what is the distance? This distance between the point and h is y. So WL square by 8h is capital H value, horizontal reaction, into y. Y is a vertical ordinate of the point selected. Right. What is the other load you have? UDL. This part of UDL. But how do you write moment for that? W into x by 2. Total load is W into x and the distance is half of x. So x by 2. So W into x is the load value and x by 2 is the distance. So Wx square by 2. So this is moment value at any distance x. So just for the check, let's substitute x is 0 means what? Point A. So x is 0, first term is 0. X is 0 means what is y value? Is also 0. Y is 0. X is 0. So total 0. Mx is 0. Right. So that's how we can check the equation that you wrote with the boundary conditions. Right now, what to substitute for? So you have ordinate here that must be substituted for in terms of x. So that is already from geometry. You are able to write relation between x and y. So that is this one, 4hx into L minus x by L square. This equation is a parabolic geometry that should satisfy this equation. If there is a parabolic geometry, that geometry should satisfy this one. Okay. So now in place of y, we substitute this value. That means 4hx L minus x by L square. Okay. Now all other terms remain same, nothing to substitute. First term as it is WL by 2 into x and third term is as it is. Okay. WL by 2 into x and Wx square by 2. The second term, that means moment from horizontal reaction, is having geometric quantity y, that means ordinate, that should be substituted in terms of x. So that is by parabolic geometric relation, the equation that parabolic geometry should satisfy. Now you have to expand this term and that you are able to write this one. So what you have here, see, L square and L square is getting cancelled. Okay, 4hx into L, 4hx into L into W, because this L square and L square get cancelled. So divided by 8h remains. So what you have, first term is W into 4hx into L, that is this one. So minus there. So minus of minus plus for second term, and w into 4h x into x square, and divided by 8h is common, and third term wx square by 2. Right. So now you simplify this 4h. So let me clear that extra line that you got. Okay. Right. So 4h, here you have 8h. So divided by 2 you get. Same here, 4h you have, and 8h you have, divided by 2 you have. So what is here? WLX by 2 minus WLX by 2. So what you have? Nothing, 0. So same here, simplified two terms. Same here, WX square by 2. This became WX square by 2 here. I wrote it simplified form here. So minus WX square by 2. So total together it is 0. So mx value is 0. Means what? What is mx? Bending moment at a distance of x in the arch. X can be any value from 0 to L. X any value from 0 to L. So you take any section. So mx is always 0. Okay. So this is how we prove that when you are constructing a parabolic arch, uh, when you expect that there will be only UDL on it, then you can say, or you can design that the arch uh, as a funicular shape, which means you can take only compression and go for design. So bending moment is 0. So stating that the condition is you should have a parabolic shape with UDL on it. So the load is restricted. Other loads, say if you have a point load somewhere here, and this statement is not valid. Okay. So this is only for if you have a parabolic arch. If you have a full UDL, then bending moment is 0 in the arch. That means funicular shape. Okay. So hope you understand this topic. Same, if you have any doubts, we will have a GMeet conference for all the doubts that you have to be cleared. Okay. Thank you so much.